then the fabrication comes in. Compiled to all this, whatever we design today, we call it as functional art. Why functional art? Because I'm just not an artist, I'm an architect also. So whatever I'm designing, I design with a purpose so that it can be used. It has to be a functional art, whether it is an architectural building that I'm doing, or whether it is a product, or whether it is an interior space that I'm trying to design. Everything is a functional art. So I want my design to be more artistic in nature. I want them to be responded because it has to be an interactive piece. That's what I look at as my design. Everybody may have their own ways of looking at things, but for me, I call them as functional art. Okay. So coming to our projects. Yeah. Yeah. So this is a project that we did long back in 2017. This project came to us as a small installation that we were supposed to do. We were in the practice till that time for almost 10 years of this kind of the practice that we were doing. So this has come to us an installation. So we were supposed to design an installation which had gears. Make in India is a gears. Okay. So we were supposed to design that. This came with a certain cost, and that cost was 4 lakh rupees. 4 lakh rupees में हमें installation करना था. That's the thing that, at the initial stage that came to us. And for the first time, a project came to us where we were trying to do an installation in an airport. So this was a T3 International Lounge that we are doing at Delhi. Okay, so this has come to us. Now the challenge is, since it's an airport, we thought, we have to go beyond now, because for the first time we have to put everything into it. हम नहीं छोड़ सकते ये जगह. Okay. So 4 लाख रुपया just gears. But we thought, सिर्फ gears तो सब लोग करते हैं. As an architect, what can I give other than gears? So we thought, let's design something which is out of the world, which an architect will never do. So we thought we'll design a clock. So now clock means there is some kind of a discipline that has to be involved into this subject now. So clock has got certain kind of a precision. Architects are always out of precision. हमारे लिए आधा इंच, 1 इंच, 2 इंच, 3 इंच, 1 फुट कभी मायने नहीं रखता है, क्योंकि लेबर्स को समझता ही नहीं है वो चीज़ साइड पे, है ना. फिर करेक्ट करो, फिर भी नहीं समझेगा, फिर करेक्ट करो, समझेगा नहीं, काट कोना रहेगा बट मिलेगा नहीं. बिकॉज आवर लेंथ्स आर डिफरेंट. सो कभी भी हमारे डायमेंशन जो मैच नहीं होंगे, वी विल ऑलवेज हैव एरर्स. और ये एरर्स का फायदा म्यूनसिपैलिटी के लोग उठाते हैं और अंडर टेबल खाते हैं. ओके, दैट्स द प्रॉब्लम. सो इन दिस केस इट वॉज अ प्रिसिशन विच वॉज इम्पॉर्टेंट फॉर मी. नाउ एज एन आर्किटेक्ट, यार ये सारे दायरे से मैंने जिंदगी जी है जहाँ पे मेरे लिए प्रिसिशन ही नहीं था, एंड सडनली वी आर एंटरिंग इनटू प्रिसिशन वाज द टफेस्ट थिंग. And mind you, when I'm saying clock, it has to give time, right? It has to show time. Very important. And the best joke is, this is not 2 feet, 3 feet ka, but it is a 40 feet long wall that we got, and it's a 40 feet long clock that we thought we will design. अब ये 4 लाख में तो हो ही नहीं सकता था, पॉसिबल ही नहीं है. हमने उस वक्त कुछ प्रोजेक्ट्स किए थे, थोड़ा बहुत पैसा आया था, तो हमने सोचा ये सब पैसा इसमें लगा देंगे. So we put almost 16 lakh rupees to execute this product. कभी कभी एक्सपेरिमेंट करना पड़ता है. We did that experiment. So we put 16 more lakhs to get this project. Okay. Now that's a very complicated thing with gears revolving into one another, and end of the day they are supposed to show time. So basically we thought we'll design a concept of a human being, a human brain, because human brain always thinks something or the other, and everything is with respect to the time. Whatever he is thinking, it is with respect to that time, is what we thought, and we designed a human head, and from there the gears continue, and then it ends up into the time. That's what we thought about. But काम करते करते we realized that at the mid stage we realized that this clock that we were designing, the panel that we had, the 40 feet long panel that we had, it is not straight. It's got an angle between. Center mein we have got a big angle which is turning its surface at 45 degrees and going back again, and then the surface. Now that's the trickiest thing. So having gears in straight, एक तो gears was easy. हमने clock was easy तब तक जब तक हम लोग हमारा research perfect था, and when it was a flat wall. The moment it changed its gear, its direction, that became difficult because we had to interconnect them at a degree. That was the difficult part. Yet we did it. So So this was the experimental thing at the initial stage. On the right, it's working with servo motors. On the left, we were just trying to understand whether they were working properly or not. So this was the experiment that we did at our factory. So that's the installation that went on the site. So this was taken in 2017, that video. It's in an international airport. So that's how all the gears are interconnected. There are only 3 servo motors that we calculated to a precision. In 24 hours span, the clock leads. I mean, it gives an error of 2 minutes. So every 24th hour, we have trained a person, he has to go back and reset it. He resets it and the clock is ticking again. Okay. Fortunately, 6 months back, I had a friend who was going abroad, and he had a flight from Delhi airport, T3, and it's an international lounge. Regular rehta to sound, it's an international lounge. He went there, he clicked this video for me, and then he said, "Sir, clock chal raha hai, it's ticking." So it's almost 8 years now. A clock like this, that huge, having almost 200 gears, designed by an architect, it's still working and showing time. So we were so happy कि बाबा चलो हमने एक ऐसा प्रोडक्ट बनाया जो चल रहा है आज तक. Many a times they don't work, right? कुछ ना कुछ errors होगा, कुछ ना कुछ problem होगा, चलेंगे ना. 8 साल हमारा machine, not even one single call till date. Okay, 8 years, not even one single call. Fortunate enough कि बाबा हमारा ये clock बन गया, and it is there, still existing. तो आज जब हम लोग आते हो सुन रहे थे 40 years में buildings खत्म हो रही है. 8 साल मेरा clock चला है बस. Just thinking, good. कुछ तो बना है. So anyways, then the clock as an installation as an architect, I could do it. Then this is like a bench, it's a dining table that we did for a classic marble company. It's a marble company that we did. This was the first time that we got our 3D printers in place. 3D printers live, we were experimenting as architects, but we miserably failed. As architects, we are also designing, we are also producing. We miserably failed understanding the technology of 3D printing. But today we are masters at that. But at that given period of time, we failed. But good we failed, because I think that was the wrong thing to use in this case. Then what we did is we built structurally, we built a metal detail inside, because your solid stone mein karna was the most dangerous thing, because if you have to ship it from one place to the other or move even in your own area, a solid marble engraved, it may break. Even a minor accident, it may break. So we thought we will use a metal structure inside on a tessellated format. We designed this using again programming languages, and then we got this metal structure intact. Then we used only 4.5 sheet of a marble for this 16 feet long table. Each and every piece was cut in such a way using water jet machine, so that all the grains match with each other to get that kind of a design detail process. End of the day, you can see that all the grains are matching. That is very important. It's not that you are just making a product and you are delivering it to your client. Your details have to be matched. Every piece, every grain has to match to each other. So that's what we could do end of the day. You can see the flooring and the table that has been designed. They look as if it is coming jetting out from the floor. Okay, the same marble was used to execute this product. So we need to understand how to deal with materials. In this case, there were 2 different materials such as metal and the material such as stone. The thing is, stone or metal, ये दोनों अलग materials है. Most important thing is binding. The binder that you are going to use to paste stone onto metal. That is also very important, part 1. Part 2, metal will always change its properties if it absorbs heat or cold. Then the reactions will be different on the adhesive that we are trying to use. That is also important. You just can't use any adhesive and get these kind of projects done. You can't. Okay. So there are specific adhesives that are necessary when you are doing these kind of projects. You need to understand that as well. As architects and designers, we have to do a lot of research on materials that are available to us in the market. We just can't say, यार मेरे carpenter ने ये बोला था, या vendor ने ये बोल दिया था और कर लिया. You have to experiment them. You have to come back, understand, multiple usages करो और काम करो. The other thing is, in this case, you can see that each and every grain has matched continuously. from one end to the other, right? But the logic is, कितना भी मैं काटूं, कितना भी करूं precision लाने में, I can't achieve that. In this case, we have achieved 70% grains. बाकी 30% grains हमने match नहीं किया है. But yet you have seen that it has been matched. How did that happen? Can somebody tell me? How did that happen? Teachers? Anyways, I'll tell you. We are architects. Okay. If you understand the materials very well, okay, you can fool your clients. In this case, we painted on the marble. We just painted on the marble. But सिर्फ painting नहीं किया हमने. Even if you grind the marble up to 2 mm thin, from 18 mm to 2 mm thin, still you will have the grains. You will not lose the grains. We have done epoxy paints on that. Marble has got a property to absorb. So we did the painting to that an extent, the marble absorbed the paint that we did on top. To that an extent, तुम कितना भी grinding करोगे, तो marble में वो texture रहेगा ही रहेगा. So we have not lost the texture. That's the whole logic behind it. So as an architect, you have to be aware of all these things. Materials का research अगर नहीं करोगे तो हम हमारा projects को execute नहीं कर पाएंगे. And my client is a stone vendor. He is the biggest stone company in India. That's classic marble company. उसका VVIP cabin में पड़ा हुआ है. वो ढूंढ रहा है कृष्ण ने साला कैसे बनाया ये चीज. How did he match? But हम तो उसको बताएंगे नहीं, right? You're architects यार, हम सब कुछ बताने तो कैसे चलेगा? I can tell you guys, but you don't tell them, right? Next time कभी गया उधर मार्बल खरीदने के लिए, इसमें तो सर इसने 30% मैच नहीं है, don't tell them, हाँ? Okay, so अभी तक हमने बोला कि बाबा आर्किटेक्ट सब प्रोडक्ट बना रहा है, सिर्फ प्रोडक्ट डिजाइनर प्रोडक्ट बना रहा है. नहीं, ऐसा नहीं है. हम आर्किटेक्ट्स हैं यार, हम बिल्डिंग भी बनाते हैं. So this is an IT park building that we did in Navi Mumbai. Okay, so it's a 32-storied building designed by one more architect. The building was designed by the other architect. I only designed the facade of those 5 floors that was given to me and the interiors of that project. Okay. So in this case, the project was an IT park building. IT park generally, very few people are doing it. So fortunately, it came to us. But the case is generally IT parks में हम लोग glass use करते हैं, ACP use करते हैं. That's a tendency. और marble use करते हैं cladding में. That's a tendency. Now we thought, why do a regular thing? Let's change the texture of these buildings. Let's change the environment of these kind of buildings. So we thought we will come up with a proposal using bricks. Okay, using high density bricks. So the whole facade was almost a lakh square feet of a surface area which was supposed to be designed. 5 floors of a parking bay was available to us. And mind you, this is the first steel building, high-rise steel building of India, 32-storied. Okay, completely done. 5 floors of parking bays. When I'm saying steel structure, there's a lot of vibration that will go into the building. And then it is a parking bay. All the time there is movement inside the space. Okay. And then, since it is cars and vehicles that we're looking at, that means the temperature inside the building will also increase. Okay. So we thought, let's come out with some sustainable material, such as brick, which will also reduce the temperature. Right. So hence we selected this material as the base material. We got this high density blocks from Mysore, and then we cut those blocks. Usually brick comes with a certain kind of a size. We cut each block into 5 multiple pieces so that we can reduce the cost. Right. Then how do we cut it? 1 lakh square feet, that means 1 lakh bricks, cutting 5 pieces each, time schedule, kya hoga? Then we have to build a machine on site like this. I built a machine where I could cut 20 bricks in one line. So within 1.5 to 2 minutes, I could cut 20 pieces. So that's how we could build a machine, so that we could get that kind of outcome of the bricks. Bricks to ban rahe hain abhi, but bricks ke sath what is the design that we can do? So we created multiple patterns on site. This is nothing to do with computational programming. This is just on site laying and playing around with bricks. That's what we did. Finally, we came to a solution where we thought we will have this kind of a facade. Okay, this kind of a design detail that I'm trying to show you. we thought we'll have this kind of a facade on the surface of the building that we got. So hence, those are different kind of types, the way the brick was cladded onto the facade. Okay, so we were given a concrete surface, the lightweight concrete surface area, the facade building that was given to us. Then we thought we will paste these bricks onto this facade. But how do we paste it? What is the material? What is the adhesive that is available? Part 1. Part 2. Bricks, they are very attractive to algae, right? कुछ दिन में मौत जम जाएगा, प्रॉब्लम है. That's the reason why majorly people don't use it. Correct? इसको करेंगे क्या? So we have to find out नए resources. We got something called a nano coating. What we had to do is, before pasting these blocks onto the facade, we had to dip each and every brick into a nano coating material, seal all the 6 sides, of the brick before pasting onto the wall, so that during monsoon, the rain doesn't percolate into your brick, the water doesn't retain there, and there is no algae which will grow onto it. So this is the protection that we have to do. Brick to sab karte hain, but the answer has to be different, right? So we have to find out that solution, part 1. Part 2, you are also seeing brick where these kind of vertical pieces, the brick is getting cladded onto the surface like this, vertical, it's not getting cladded like this. The surface area of the brick is, in this case, is more, but in this case it is just 12 mm thin. So getting this 12 mm thin pasted onto the wall, which is a steel building which has got vibrations, what is the adhesive that you need to use? That is again important. So we have to practice all this at the initial stage so that we can derive to a good solution and get the building executed. So we had all those design details, multiple challenges before we could execute that building. So that was the surface that was given to us. We had 17 different people. We taught them how to do it on the floor first so that we get precision. 5 mala with that height, having these bricks laid together in one line, right? They are laid in absolutely a straight line, and to achieve that, it is not easy at all. It's got multiple layers, okay? Then there is also ventilation in between. That's how the building looks like. You can see the precision. The building is done 4 years back, it is still like that. So there is no growth of algae on it, no growth, okay? The thing is, best part is this nano coating material will protect your brick a minimum of 5 years and maximum of 10 years. 10 साल के पहले एक बार वापस जाओ, स्प्रे लो, स्प्रे कर दो, within 10 years nothing will happen. So that's how these materials are there, okay? Look at the detail, look at the shadows that are falling to us. Luckily, this surface, the building that came to us was exactly placed in a east and west direction. So the play of light was very beautiful in this case, okay? So those details were precise. Internally the jalis that was designed so that we could get cross ventilation, have good amount of ventilation and still reduce your temperature inside. We built these kind of jalis, but the jalis may look very simple. Do you know? These jalis are vertical, half cut brick, laid on just a 12 mm slice of a brick. Now that's the stability of the product. And this is something we need to understand. Itna easy nahi hai. Bricks, छोटे bricks, laid one above the other as a slab, continuous slab. Again one above the other. Now the bonding agent has to be perfect. In this case, you can see the bonding agent there. The bonding agent has to be just 4 to 5 mm or 6 mm maximum. Even if you increase from 6 to 7 mm, the bonding agent will not, bind these two materials. That's how important it is. Not more than 4 to 6 mm. 7 mm, khatam. It will collapse. That's again the biggest problem. So you have to be precise. So the details are something, the information is something which has to be sent to your labor, because you are not going to execute all this. Your labor is going to execute. Saab bana diya, saab waise hi kar rahe. And they did it. In one of the areas, instead of 6 mm, they went up to 14 to 15 mm without saying. While the work was going on, 2 महीने में 3 जगह से brick गिरा. And like client, अरे sir, ये क्या materials use कर रहे हैं आप, ऐसा कैसा है, वैसे कैसा है? I mean, we had a big fight. Then we had to call the vendor. And the vendor is ready to give it in writing. 10 years, nothing is going to happen. 10 years के पहले हम लोग आएंगे, वापस check करेंगे, grouting करके चले जाएंगे. Next 10 years you don't have to do anything. So that's the kind of an adhesive that they provide to us. अब ये गिर गया. Then We realized that बंदे ने 16 mm तक ये material bonding agent को use किया, because of which it did not bind to the base material. So those are the errors. Then we realized नहीं चलेगा. 6 mm means 6 mm only. You can't just increase because हमारे पास material पड़ा है, चिपका दो. So that was all about the facade. Then the interiors that we did inside was almost a 20,000 square feet lobby that we got. And the lobby, we didn't want to design the way typically your lobbies are designed using Italian marble, ceilings and wall coverings, everything. We wanted to go in a different way. While coming back from Goa, we saw this kind of this was not the tree, but this kind of a tree was what we had seen, which was lying down on one of the side of the roads. And we realized that why can't we have that kind of a design detail? Let's copy that design detail as an art installation inside the structure that we were designing. So quickly when I came back, I drew that sketch. Usually I make a sketch, so I made that sketch, which is 120-meter long sculpture, weighing almost 80 tons, and it was supposed to be suspended from the ceiling. So that was the design that we thought we will go for. Then after the sketch was complete, we made a 3D rendered model, 3D model inside using the softwares. We got that thing done. But after making the model, a 3D model in the software, we can't end up there since we have to execute. We have to actually 3D print the model and understand how it is going to look like. When it is placed inside the building, how will it look like? So we had to make that actual model of the site and the installation and place it inside with the human scale, just to understand whether it is not going to overpower the space. So finally we did that. 80 tons of load was supposed to be suspended from the ceiling. 120-meter long sculpture, अगर हम 80 tons load को अगर suspend करना है ceiling से, तो what are the things that we need? Right? There might be huge cables, metal structures, बहुत कुछ होगा, but यहाँ वैसा कुछ नहीं है. We plotted 200 separate points on the whole installation of 120 meters long. Each point can take a load of 600 kgs. Each point. Okay. Now each point taking 600 kgs using a 6 mm thin cable is what we have used. 6 mm thin cable has been used to suspend this whole ceiling at 200 different points so that we can distribute that load in 200 different areas. And the whole thing got suspended from the top. This we could do it because we had to find out a vendor who can help us out in terms of giving us this material, these cables, SS cables, which are of only 6 mm dia, so that the whole sculpture looks seamless. It looks as if it is floating in air. The whole idea was that. But we can't do that, right? It's not magic. We have to suspend it. But this is the cable that we could get it from there. Okay, this is the Hilti cable that we get. The whole product was unrolled. Unrolling is something which we may have learnt in first year students. I don't know whether you've learned that unrolling of your surfaces, of the objects that you tend to do. Unrolling is something which you need to learn in a much better way. जो फर्स्ट ईयर में कर रहे हैं, make sure that, because आज भी हम लोग कर रहे हैं काम. Basic design and graphics is what we are working with. So here unrolling was done. We understood the calculations. The whole project went on. We had to do metal fabrication, use metal laser machines to cut this so that मेरा cost reduce हो सके, and we could get that whole installation done like this. So you can see the cables on top. कई cables दिख रहे हैं. You can see, but it looks seamless. So it's a 120-meter long art installation. We didn't want anything on the ceiling. We wanted only this art installation to respond to the people who are going to move below this and understand that they are in a different space by itself. So hence, we had this kind of a design detail. This thing we did during COVID. We wanted that whole sculpture to have a mirror polish on top of it. We wanted that to be chrome. The whole idea of this installation was what? It's a chrome installation on top, which is actually trying to take the impressions of the people moving below and their information. The concept was that. But unfortunately, we had to deliver the project, so we had to use just silver leafing and get the job done. Because chroming karna, again, it was a 6 months job on this product, so which we didn't have time, so we had to do this. So then, in that space, we also designed, since I'm an architect, during college, I was best at making models. Okay, and now this is a space that I got to build a huge model, because it's a 120-meter long wall that I got. So what I did is, I stay in Navi Mumbai, and the project was in Navi Mumbai. So we built a whole Navi Mumbai map, a 40 kilometers ka Navi Mumbai map on a 120 meter long canvas that we had. We built the model having each and everything in place. The road network was there, the buildings were there, railway stations were there, everything was in place. And the developer whom we were working this project, his projects were highlighted because he was doing multiple projects in that space. So we just highlighted his projects and the whole wall has this canvas. So it's got an art installation here. The best part is when people who are working here, the building is 32 story, 22 lakh square feet of a space, almost I think 20,000 people work in this building. So imagine 20,000 people working, of which at least 2 to 20,000 or maybe 10, 12,000 people, 2 to 3,000 people working from Navi Mumbai. When they are working here, when they see this map or a model, they try to interact with the model, thinking that this is where we used to stay earlier, my parents who used to stay there, my school was there, this is the college that we used to go. You know, that's the interaction between the model that we had. So what we understood by designing this, knowingly, unknowingly at times, when we design such kind of things, we understand that these are interactive spaces that we are trying to build. They may be just wall panels, but they have certain kind of emotions that they respond back. So that's something, a learning that happened to us in this case. Then this is a bench, this is an information table, information bench that we designed, a reception table, completely tessellated. But the most complicated thing is, what we do is, hamare office mein, har bar we take up challenges. This may look very simple to you, right? Just having tessellated forms, triangulated forms, correct? Yes?
Yes.
But the thing comes here, when you're joining these lines, every triangle, every length is different. All the lines have to travel from one surface to the other and they have to end. So the most complicated part was that. Getting that in place and hell lot of time, because it's not easy. It's not easy at all, because it's every piece, from one end it is smaller, the other end it is bigger. Again you got to join to the other triangle. So tessellations may be easy, but how do you make your object complicated and define it? Very important is defining your product. So in this case we could do that. Then these are few benches that we have designed for the space. Every bench, every detail that we have designed in this 20,000 square feet is a installation that we did. They're all sculptural pieces. Even the flooring has got some inlay works in it, SS inlay works. Those are the benches where people today, it's a running IT park. So people are using it, they're enjoying the spaces. Then in this case, since it's an IT park building, also we have got lift lobbies. We all know that there are lift lobbies in every building. We thought, why should the lift lobby look the same? Why should people use the lift information panel the same way people use it everywhere? We thought we will create lift information bots. So this was a lift information bot that I designed. Got inspired from Big Hero 6 movie. I don't know how many people have seen this movie. I keep watching movies a lot. Okay. I get inspired a lot from these movies. So there is a micro bot in that movie. So I thought, why not design that micro bot as a lift information bot in my space? So we made a sketch of that, used materials, having machines. We created those kind of bots, micro bots. So lift information bots, where in this case the panels were inserted in this. Okay, so these were bots, and then we have these cables through which, those pipes through which my information has to be sent, especially the cables. So that's how they got designed. Those lift information pads are inside those bots. You have these pipes on which these are actually suspended. So the whole thing looks as if it is being lifted in air. People come there, they press the button and they know where they're supposed to go. The interaction between the user and the information pad is completely different. People feel like as if they are in a different kind of a space. Then we go to one more project that we are doing in Bangalore. This is a bungalow. It's a residential project that we are doing. In this case, I'm not showing you the bungalow. I'm only showing the products. Everywhere, what we are trying to show is the project has got certain kind of products, and these are built. This is a column. Every time when we make a bungalow, if it's an individual and a huge bungalow, you will always have a canopy. You will always have a porch. Every client or every person in India today thinks that he wants to build a White House. Correct? सबको लगता है कि मेरा घर White House जैसा होना चाहिए. So in this case also my client had that wish कि मैं भी उसके लिए एक White House design करूँ. Where I said मैं तुम्हारे लिए White House नहीं design करूँगा, but I'll have my own kind of house which will be a specialized house for you. So I am not going to have that same typical Doric order columns or Corinthian columns. We need to change. Why should I repeat the history? People have made mistakes. History is mistakes. We need to learn from those mistakes and create new things. You are not supposed to repeat those things. We are supposed to create new things. Here we thought, let's create something new. The fluidic art or the fluidic design that nowadays we are looking at. Mimicking nature and getting our designs in. So we thought we will do this. But I couldn't convince my client at the initial stage. So he said, नहीं मुझे नहीं चलेगा, मुझे वही columns चाहिए. So I said, मेरे लिए भी नहीं चलेगा, मैं चाहता हूँ कि you need to have different columns because the project belongs to me. You may live in that, but the project belongs to me. So I had to make these number of columns, 3D print, show the client that these are the columns that I can build for you. But yet I could not convince him. You can see the scale of those columns. By putting a human figure, you can understand that. So then I had to tell him that column 8 foot का print करके दिखाया उसको कि भाई column ऐसे दिखेगा, उसके ऊपर projections करेंगे तो ये होगा. Yet he did not get convinced. When he did not get convinced, I said, yeah, let's 3D print a 40 feet column and show it to him that how it is going to look like. So I had to literally build that 40 feet column to my client to convince him that your column is going to look like this. And finally, after building this, we got the approvals and we convinced him and we got this finally made. So the whole logic is, at times, doing these kind of things are easier if you have the knowledge of machines. If you have the knowledge of machines and how to use them, what material and whether they can be built or not. So we could design all those details and make sure we go into the process of execution. So when it went to the process of execution, what is the material that I am supposed to use? Because we had 22 columns like this, just not 6. 22 columns, same details, same design. How do we do that? Reducing the cost. So we use lightweight concrete blocks, multiple pieces, more than 5.5 lakh pieces were cut and shipped from Mumbai to Bangalore. जिसमें 30% टूट गए थे, मुझे वापस बनाया, but cost nominal था. So we cut them. There is an RCC column in the center. This was stacked all around, one above the other. On the center you see that's a 3D printed column. On the right, उसका finishing चल रहा है. Then the columns were like this. You can see the scale. You can understand that these columns can be done. It is not that they are just in your dreams. It is not that they are just in your drawings. 3D में हम दिखा रहे हैं. It's not that. You are trying to build them actually. So the columns look like that today. So you can see the detail that was initially envisioned. It got executed by convincing the client to that an extent that he understands that what we are planning to give him. So at times they are difficult, but you can still build them. So that's the detail that you are trying to see. Those same columns, the same design detail. At the initial stage, I said the information that goes from an architect to your labor, there shouldn't be loss of information. The information has to be passed on perfectly. This can only happen if there is a mediator in between, that is your machines. If the architect, the machines and the labor, they work together, you can get your end product. So that's how they look like. The work is still going on. You can see the first image that I showed you as a slide, and this slide, the columns are intact, the distances are intact, the size is intact. So everything is perfectly been placed and made. So this is something you can achieve as a designer if you know the language of machines. If you know the technology in a much better way, which is necessary today. Then we are also doing one project, a bungalow in Kolar, which is again in Karnataka. This is a 9,000 square feet bungalow that we are doing. This is the bungalow where I was talking about the 20 mm thin slab. In this case, the RCC consultant is also us, because we didn't have an RCC consultant who could help us out in terms of building this project. We said we will do it, we will go back. We made the project, we went back to do the calculations, and he had to do the calculations and get it corrected. And then uska certification ho gaya, because we need to submit a certificate of an RCC consultant, which is must, right? But at the initial stage, I couldn't convince him because वो तैयार ही नहीं है, जिंदगी में उसने बनाया कि वो तैयार नहीं है. 20 mm thin slab possible नहीं है, but we did it. So that's a 5 BHK plan. It's spread in almost 12,000 square feet of a space. We have got 9,000 square feet as a built-up area with landscapes all around, with courtyards inside. We had this kind of a parabolic curved roof. End of the day, while working, we changed the whole roof to that an extent that you have got too many bends. So it's not just one single parabolic roof, but the whole roof is parabolic. And we had brick, completely brick is what we have used in this building. Yes, we have got RCC columns also, but completely brick. So initially we had to make this model just to understand whether it is possible or not, whether the structure is feasible or not. We did this as a membrane. Then the bricks and everything, the details were sent to the site. So we are almost 1,000 kilometers away from Mumbai, trying to teach our people, give them information, tell them where you are supposed to place the brick. So that's how we could teach them by putting numbers on the brick and tell them these numbered bricks are supposed to be placed at this distance, so that you can get this kind of a design formation, which is a tessellated formation, and get the design outcome as it is, as you are designing. So no loss of information again. So that's how the details look like, completely parametric design detail, which we could finally, whatever we conceived as a design, we could execute it. So internally also everything is brick. Where the columns are, we slice the brick into smaller pieces, cladded on top of that, so that it looks completely one piece brick detail. At the bottom of the roof, we used wooden so that we can curtail the heat, reduce the heat. Of course, on top we also have a 12 mm lightweight concrete block, which is fixed on metal. So overall, it is a 20 mm thin sheet of a slab. So the work is still going on. These are bungalows. I mean, these are new things that we are trying to develop, build them. That's metal. You can see people standing on it. It's just a 6 mm sheet metal which was cut in a tessellated format. Tessellated means triangulated format. Triangulation is done in 3D softwares. We cut them, we number them, we take them there, and then everything is joined together. The way we want it is joined together so that we can get that kind of a roof. So that's the detail that we could achieve. You can see how thin the slab is. So as a designer today, as an architect today, we can dream things and we can also build them. So you don't have to worry next time when your professors say that these can't be built. You can tell them that these are possible and we can still do it. And answers are there. Okay. So that's how the thing got delivered. So left is the roof. Now we have cladded with lightweight concrete block so that we can curtail the heat which enters in by having this at the top and having wood. So internally it is completely, the temperature reduces more than 6 to 8 degrees inside the house. So this is a bungalow. Then again going back to tables. So this is again information table that we designed. We quickly run through this. So these are, this we did in Bandra, that is in Mumbai. So for a lobby again. So from a sketch to a design, it's again a 25 feet long information desk. Not one piece, two pieces, mirror images. Okay, huge lobby, but mirror images. So getting mirror images in place is not easy again. So we did 3 installations in this case using 3 different materials. Same area, but using 3 different materials. Divided the whole product into multiple pieces, got inspired from this Avatar movie, Waterworld. So using WPC as a base material and then spraying that with your stone powder, we could, and then you can see those holes through which we pass on our structural members. So steel rods are inserted into that so that you can get your structure stable. So that's how the whole thing got converted to. So spraying of composite marble was done so that we can achieve the end product. So those are 2 mirror pieces. You can see how similar they are. So no loss of information. This is something which we need to understand. No loss of information. Okay. It's not an edited image. It is an actual image. So that's how it looks like. So from the design to execution, you can see that these are possible today. Okay. Then we did a small art installation inside the same space. Now it's an art installation, but yet we wanted the strength to be there, because even though these are art installations, these were very accessible, easily accessible to people. So people can look at it, they can touch it, they can hang on it. So we didn't want any accidents to happen. We could have done this by using 3D printing also, but we made sure that the stability is there. So we used MDF as a base material, then sprayed again your composite marble. Composite marble is something which we are using more and more nowadays, because that protects and that seals your product completely so that the moisture doesn't go in. So the best thing is, because it is resin based, it seals completely and it is moisture protecting. Okay. So that's how the whole installation went on. There is a mirror at the back on which we cladded this. So it appears as if it is a double image. Then we did a separator. It's a screen, baggage screening partition, where we have a baggage and an entrance lobby in the same space. All these 3 installations were done in the same space, but using 3 different materials. All the 3 installations were mimicked from nature, We mimicked this from the water areas because there are backwaters in Bandra. So a lot of mangroves and everything. So we thought we'll use corals and mangrove details, mangrove roots to build these kind of designs. So all the designs that you are seeing are being mimicked from the water world. Okay. So we divided this into multiple pieces. Almost each piece again has been divided into 4 parts. They were engraved. They were engraved using lightweight concrete blocks in this fashion. They were pasted. You can see the numbers. There were almost, I think, 4,000 to 4,500 pieces, which were joined together. So they were joined with adhesives. The adhesives are not regular. They are cement-based adhesives, but they are not regular cement-based adhesives. These are block adhesives. So by using that, we stack them one above the other to get that kind of a design outcome. As a design detail, whatever we detailed out earlier. Also, we incorporated light into it so that we could get this kind of a end outcome. So you can see it's a screen which was designed so that we could achieve that kind of a precise detail that we were looking at the initial stage. So all the details are intact. Light got incorporated at the end, which initially we never thought that we should incorporate light into it. But at the end of the day, yes, that was the last minute thought. But the design had that flexibility to insert light into it. So that's how it looks like. So doing these kind of designs is fun. Then comes a table, which is one of the most trickiest and after doing so many projects, this was the toughest project that we ever did in our life till now. So why? I'll explain you. This is a table that again has similar kind of a design detail using stone and metal. So basically in this case, if you are seeing the texture, those lines that you are trying to see, we wanted those lines to be there on the product also. Earlier you had seen it's all marble, but in this case we have got marble and we wanted those lines. And those lines were supposed to be done by using metal, that's brass. So bending brass, inserting brass and putting that on top of that was the most difficult part. So we have used ply at the initial internal thing rather than metal. We used ply. We got that thing done. Cut metal again. Cut stone using again computational programming. We got the design detail intact, but while sticking metal, it was the biggest pain that we ever had to pass through, which took a toll to us for almost 6 months. We delayed this project just to make this table. Huge losses, but yet we could complete that as the design process that we had done. End of the day, all this metal was stuck to that an extent that you get that as a design detail. You are not losing a single piece of an information that has been initially designed to the end product. So that's how the end product got resulted into. So the whole team was happy, thinking that chalo humne kuch to achieve in life mein. So everybody combined together and they said chalo photography karte hain. So it's fun doing things, it's fun learning with this kind of an experience. A lot of hard work goes, बहुत बार नींदें चली जाती है, पैसा का भी नुकसान होता है. But if you thought that you want to do a project और करना है ना, end of the day I want to deliver. If you have that thing in your mind, you can do it. So we did all these kind of projects. Then came recently we did this staircase, which was designed by Andrew Palfinger. He's an associate to Mad Architects New York. So he was there in August last year. We do unfolds, so which is again a knowledge sharing platform where we invite different architects from different parts of the world. They come here, they take lectures, they teach students, they teach architects. So it's a 6 days program that we usually do. So 2 days each with one of the architects, and then they teach AI, they teach programming languages like Rhino and Grasshopper, Blender, Cinema 4D. So we selected one of the designs that was done by him, Andrews. So because he was coming here, we thought we'll build one object that he has designed. We could have taken on his Instagram page all the designs that he has done in life are all unbuilt. He has not built any design. He has only designed them, and they are there as photographs on his Instagram page. So we thought we will use one of the things that he had designed, which is a structure again, not a painting, but a structure. So here in this case, it's a staircase that we have selected. We thought we will design that using again 3D print technology. You can see each step, that's one step in which we are inserting metal so that we can give stability to the object. So that's how the 3D print model was done. Then a mold was created, of which we create, you can see those multiple pieces joined together. Each piece is again interjoined. So the beauty is they're interjoined with each other, and it looks as if it is a one continuous piece of a staircase. So, but everything is cantilevered from that central, central one spine. So it's called an exospine. You can see that central spine. and everything rests on that small plate at the bottom. So that's how the whole staircase got made. It's a cantilevered staircase. Each and every detail that he tried to design in his software has got executed. All this, when I'm trying to show this kind of designs, is all about information. There is no loss of information. All the time I have been telling that there is no loss of information. You need to understand this point very well. हम कॉलेज में जो भी डिज़ाइन करते हैं, we have to deliver that. That is something which we need to understand. And similarly, when you go out, the same thing has to happen. So you can see that's how the whole staircase was detailed out on softwares. We designed it so that you can easily climb on it. It looks like as if it is just a decorative piece, but it is not. Okay, it's a structural member. You can literally climb, you can literally sit on it. We had almost 6 people sitting at one given period of time. Each one was weighing almost more than 100 kgs. This was exhibited in the exhibition. We had few people. So that day we had, we were worried, but we had 6 people sitting together. So on the left, that's Andrews. He was there in Mumbai in August. So that's how this thing got detailed out, and it's there. This is a car showroom again we are doing in Mumbai, completely with the same thought process. It's a project where, since it was a car showroom that we were trying to do, we thought we'll use chassis as the basic module. You know chassis, right? Chassis of a car. So we thought the whole building should look like a chassis. So we had almost all the design elements, the pods inside, the table, everything should look like a chassis. Even the building should look like the form of a chassis. That's what we thought, and we designed this. The project is still going on. All these projects that we are trying to show you is last 1.5 years we have been struggling to get our projects intact, placed. There's a lot of design details. Try to send the information to people, get them executed. Not easy. Simple lines, it's very easy, but getting these things in place is not at all easy. That's the staircase done with only 6 mm thin slab. Okay, thin metal sheet that we try to do it. Not easy. People will say no at first place, but they are possible. Nobody is ready to build these kind of staircases, but we did it. So that's the design that was produced, and the exhibition got done. Okay, then there's one more staircase at the upper level, which is again completely fluidic in nature. So again a 6 mm thin sheet was used to get that kind of a design detail. This is again a chassis that we are trying to design, which encases the whole building above the glass. So this is how the design was done, and the making is going on. So we are at that stage right now. We are stitching each and every piece. The whole work is in process. As we are designed, we are trying to deliver it out now. Okay. So part of glass has been installed, part of metal sheets has been installed. So this is again a